Welcome to rktutorials. Solutions to Engineering Mechanics by S. Timoshenko, 5th edition. In this tutorial, we will discuss problem set 3.2 and problem number 3.22. Find the load P required to maintain the system of levers in equilibrium with AB in horizontal position if Q is equal to 9.6 kilonewtons. That means there are two levers, AB and CD. The AB is supported at E with hinged support. CD is supported at D with another hinged support. The B and C are connected by another lever BC. Now a P force is applied here and a Q force is applied here. I know the value of Q, that is 9.6 kilonewtons. Our interest is to find the value of P so that the total system is under equilibrium. Now let us find the free body diagram for all the three levers AB, BC and CD. First of all, let us consider the free body diagram of CD. Now it is subjected to a load Q, and at D I can find hinged support. So hinged support will be replaced with two reactions. One is the vertical reaction and another one is the horizontal reaction. But there is no any other horizontal force, hence this can be 0 and not shown. And at C, since it is also a hinged support, so I can find a vertical reaction. Let that vertical reaction is RC. Now by considering the moment equation, let sigma md is equal to 0, take moments about d equals to 0, then I can find RC into L is equal to minus Q into L by 6. RC will introduce a moment in this direction clockwise and Q will introduce a moment in the counterclockwise direction. RC is at a distance of L and Q is at a distance of L by 6. So if you take moments about D, I will get RC into L minus Q into L by 6 is equal to 0, or I can find RC is equal to Q by 6. Next, let us consider the free body diagram for the lever BC. This is the BC lever, and I know at C the reaction force is RC and that reaction force acts downwards, because for CD lever it is acting upwards and for BC lever it acts downwards. Now the reaction force at B, it must be upwards to maintain the equilibrium. And if we consider sigma Fy is equal to 0, Rb must be equals to Rc and that value is equal to Q by 6. Now finally let us consider the free body diagram of lever AB. And I know at B the reaction force is Rb and that force acts downwards, because at BC the reaction force at B is upwards, hence at AB the reaction force at B downwards, and the force P is acting in the downward direction. Now let us take the moments about point E. Then RB will introduce a moment in the clockwise direction, P will introduce a moment in the counterclockwise direction. The P is at a distance of L and RB is at a distance of L by 8. Hence I can comfortably take the moments about E. Now sigma ME is equal to 0, then I can find P into L minus RB into L by 8 is equal to 0, and I know that RB is equal to Q by 6, and upon substituting I will get P into L is equal to Q by 6 into L by 8, or P is equal to Q by 48. But given that Q is equal to 9.6 kilonewtons, hence 9.6 into 10 cube by 48, which gives the value of P, that is 200 newtons, is the answer for the given problem.